This is a video about antennas for the Meshtastic system. It seems to be taking off in the UK at least. What's all the fuss about? It's this device. This is the Heltec version 3 transceiver microcontroller display, and it has an antenna for Bluetooth or Wi-Fi or maybe both, and it has a connector for the LoRa antenna, 868 megahertz at the end there, SPX connector, extremely small. They come in two different sizes, so you have to watch out you've got the right pigtail to plug into it. And of course the important thing is the antenna, because the important part of any radio system is the antenna. So here's a selection of antennas that I'm going to be testing in this video. I'm going to measure the SWR to the antenna, or return loss if you like to hear about that, which is going to be done with this device, the Nano VNA. And I'll also give the results of some range tests I did with a local node using another device, which is this one. This is another one of those boards with an antenna on it, and I use that to test the range. But first let's have a look at some of these antennas, and I can't test the one that came with the Heltec device included with the package. It's just a little coil of enamel copper wire like that one on there, and then a piece of heat shrink tubing. It works, but it's not the best, as you'll see later. I can't test it because I don't have an adapter from this SPX connector to SMA. They're incredibly expensive and easily damaged, and it's not really worth it just to test one antenna. So let's put this one to the side. It's not going to get tested, certainly not for measuring the SWR anyway. So let's start with this antenna, and this is the one when you get when you buy the Heltec device from YouTube or from Amazon. In fact, the Amazon ones came with these antennas, and the ones I got on from eBay came with these antennas. So there are various small antennas included in the package. I'm trying to screw this on here with one hand. Don't like editing video too much, so you're going to have to bear with me. So there's that little antenna. It's too close to the table, of course. There's going to be capacitance effects. So let's try to stand it up a bit away from the table. As you can see, it's resonant, and the SWR is pretty good. That's the yellow curve. And for those of you watching in black and white, the yellow curve is the curve below the blue curve. Let me just move the cursor across the marker, put it in the dip. In fact, I want to set the marker to a sensible frequency because the LoRa transmissions are at 868. In fact, for this particular Meshtastic, it's 869.5. So if I set this to 870, okay, that marker is now set to 870 megahertz, marker number 1, and you can see that the those are both S11. I'm going to have to, no they're not, that's odd. No, the yellow one is SWR S11 displayed in SWR, and it's 1.4 something. As I move the antenna around, you can see that the curves move because of the effect of surrounding objects. But it's about 1.4 SWR. If you like to talk in terms of return loss, that's 18 dBs, which is pretty good. So that's the small antenna. What I'm going to do is change the antenna now and put on the other small antenna. I'll take this one off, and let's put on this one, which is actually marked. The one I took off was unmarked. This one is marked, and the manufacturer's written on there is LilyGo, and that came with a LilyGo device that I also bought. I ordered several of these Meshtastic devices, LoRa development boards, just to see if any of them would arrive, because it's Chinese New Year, it's holiday time, so a lot of the manufacturers and sellers are having a 2-week break. So anyway, that's the LilyGo antenna, and if we have a look at that, you can see also it resonates, and frequency is a little bit on the teeny bit on the high side, but not to worry. SWR is 1.5, and let's not talk about return loss, because I think most people using these devices as radio amateurs like to talk in terms of SWR. So it's about 1.5 SWR, and the frequency, let's have a look. This is a new nano VNA, this one, and I haven't quite got used to it yet, so I'm not sure where it's displaying the frequency of the marker. Not to worry, I know I set it to 870 megahertz. So there it is, M1 870. So it's very close to the required frequency. So that's that very small stubby antenna, which is about 3 centimeters long, and it actually works very well. You'll see later when I show the results of the range tests that I did. Now let's plug in this antenna, which is a bit longer. It's about 15 centimeters maybe, and I'm going to connect it there to the S11 port. This antenna has no name on it. I bought it from the Pi Hut, which sells Raspberry Pi stuff. And because there's a LoRa hat for Raspberry Pis, they thought they'd sell an antenna. And this is one of my favorite antennas because it's not too big and good to take out portable, and you'll see the range test results are nice. And it's resonant at the correct frequency. And as you'll see later, some of these antennas are not resonant at the correct frequency. Even though they're sold as 868 megahertz antennas, they aren't. So this has a nice dip. As you can see, the SWR there's about 1.2. It's a tiny bit higher frequency, but it doesn't matter. So the SWR is 1.2, which I think is pretty good, and it's got 30 dBs return loss at that resonant frequency. So that is a pretty good antenna, well matched. So that's one of my favorites. Let's move on before this video gets too boring. Take that one off. Next antenna I'm going to test is this, which I bought from AliExpress. Very cheap. They cost £3, £2.90 or something each. The one I showed you previously from the Pi Hut was, I think, about £5, £4.90, which is very reasonable. This antenna is quite long. It looks like 3 elements in a collinear arrangement. So if I plug this into here, let's see what happens on the VNA. Sorry about the wobbly camera stuff. I left my selfie stick somewhere else. So that's the super long antenna. It's about 50 centimeters long, maybe a bit more. It cost £2.90 plus shipping, which was another couple of pounds from China. Of course, these things take time to come. Anyway, as you can see, let's turn off that. The resonance curve is not really ideal, and as you can see, the span here is 800 to 1000 megahertz, so it's 800, 900, no, 800 and 850, 900, 950. So it's got a very sharp resonance there at 950 megahertz. So I'd say that this is a 950 megahertz antenna. And if you look at the performance down at what we want, 870 megahertz, then yes, it's pretty useless. The SWR, if you want to know, is about 4.5, 4.6 up there on that yellow curve. So that antenna does not resonate anywhere near the required 868. It's a 950 megahertz antenna that was sold at 868. Thank you, AliExpress. I'm not going to bother to send them back because it was not a lot of money, and it's the experience that counts. So moving on, we've got another antenna here. This actually came with a Nuelec RTL SDR dongle, USB dongle, came with it. Has 2 different screw-on elements. This one is useless for 868. I think it's resonant over 1 gigahertz. So I tried it, and I'm not even going to bore you with it. So let's put it over here. And then the longer element, which is about 30 centimeters long. This seems to work when I checked it earlier. So let's try to plug this in. It comes with a magnetic mount, which is really nice to stick on a car if you have a car, or a saucepan if you don't. I'm going to try it with no ground plane. Let's just see if I can plug it in one-handed without it falling over. There we are. Plugged in the Nuelec. It's actually written on the magnetic mount here, Nuelec. So that's nice. And let's have a look at the performance. Interesting. What's it doing? The yellow curve is SWR, so the SWR is about 2.2 at 870 megahertz here, and seems to work better around the 900s again, but it's usable. 2.2 SWR is better than the 4 point something for this very long antenna. One word of warning with these, all of these devices, you should not turn them on with no antenna connected, because then all of the power transmitted is reflected back, which is 100 milliwatts or maybe a little bit more, and that could damage the device. So I forget from time to time and turn it off quickly, but try to remember to always have an antenna connected before powering on the device. So this antenna, I used it on receive for a while at 868 megahertz, and it worked nicely for receive, and on transmit it's not too bad, as I said, with the 2.2 SWR. Probably that would change depending on how it's mounted. Maybe putting it on a ground plane would change that, but I'm not going to try that now. So that's that antenna. Let's take it off, moving swiftly on. We've got 2 more antennas to go, and then 2 dummy loads, just for fun. I haven't done range tests with the dummy loads yet. I probably won't even bother, but it's fun to look at their SWR. So let's just connect up this antenna, which I got on eBay, and it's called a Paradar, or maybe it's Paradar.co.uk antenna, which was sold on eBay as an 868 to 950 megahertz antenna. I just checked what it said in the description, so I'm not going to complain. So let's plug that in. Actually, laying down on the table, the performance looks pretty good. When it's laying on its side, which of course you wouldn't normally do, it's got a nice dip here, around about the 870 megahertz we're looking for. The problem, as I noticed earlier, is when you stand it up, then actually it's improved. It depends on the location and the capacitance effects to surrounding things. So maybe it's not as bad as I thought. It's outdoor weatherproofed, which is nice, and comes with a N connector, female on the bottom, so you need a few adapters and cables to connect it up to the Meshtastic transceiver. And this one is giving an SWR of about 1.7, 1.8, which is fine to use at 868 megahertz. And it's got 2 dips. The lower one is at 850. That's 900, that's 950. So again, it resonates at 950 like the other Chinese antennas, but it's usable at 868. So that's not bad at all. Let's see how it does in the range tests. And now, the last antenna, which I think is my favourite one, which is this black antenna from Superior. It costs £35 on Amazon. Of course, it's sold out when I looked yesterday. It's my favourite antenna. I use that for my main node outside. The grey one, by the way, from Paradar, that costs £11.95 on eBay, so it's a third of the price. This one is 3 times more expensive. It's mounted directly onto an N-type connector with an adapter inside this waterproof box where one of these nodes goes, with a battery and then a long USB cable to plug it into a power supply, so it's permanently on charge. Let's see if I can connect this one-handed. There it is, done it. And this is, I think, the best matched antenna. It has a very wide-looking matching curve. There's a little blip near to that marker, and that marker is the frequency we want, 870 megahertz. The SWR is 1.38 at that frequency. And the blip is partly due to the cable and the connectors, because if I use different pigtail SMA cables, then I get slightly different curves with different blips, which just shows that the cable is also critical, and the connectors, they may have reflections. So it seems to be centered nicely at 870 megahertz and provides a very nice SWR. So that's the preferred antenna in terms of antenna matching for the transmitter. This one here. is Superior, sold out on Amazon. These things come into stock and then disappear again quickly on all of the suppliers, Amazon, eBay, or the others. And just for fun, this is not an antenna, it's an attenuator, 10 dB attenuator, also from Amazon, made in China, no doubt. And if it's a 10 dB attenuator, it'll work as a dummy load. If I put it onto the network analyzer, a bit of theory coming up now, because the signal coming out of this port will be attenuated by 10 dBs, hit the open circuit, all of it's reflected back as 100% reflection, goes back through the attenuator, so that's another 10 dBs, so it should give 20 dBs, that's 10 plus 10, return loss. And indeed it is giving, this is the blue curve, S11, that's 0, minus 10, minus 20, so it's showing 20 dB return loss, which is what I would expect for a 10 dB attenuator. And the SWR curve, the yellow one, is down there as you'd expect, and that's, or maybe you wouldn't expect, that's 1.2, approximately 1.2 or 1.3, which theoretically, if you convert return loss to SWR, that's what it should be. So I've never actually done that before, to actually use an attenuator as a dummy load and then check the SWR and compare it to the return loss. So that's a very nice dummy load, even though it's only a 10 dB attenuator. And what I've got, last of all, because this one can't handle any power, the one I use for testing transmitters is this attenuator, which is rated at 25 watts, again from Amazon, and it's a 40 dB attenuator. So you'd expect that to provide a return loss of 80 dBs in theory. So let's see how that performs by connecting it to the S11 port on the analyzer. It looks like I'm going to give a 1 hour lecture. Sorry about the length of this video. Okay. Oh. So the S11, the blue curve, and as I said, in theory, because it's a 40 dB attenuator, should give a return loss of 80, which of course is not going to happen. And what we actually get, the frequency of interest there, is a return loss of only 18, is that 18 dBs? No, wait, focus. It says 18, but it doesn't look like it, because if that's 0, minus 10, minus 20, that looks like minus 25. Interesting. But whatever it is, it's nowhere near 80 dBs. In fact, it's giving a worse performance at some frequencies than this little device here. And the SWR at our frequency, 170 megahertz, is 1.18, 1.2. So again, it makes a nice dummy load, as well as a attenuator. Oh, that was a burst of data I just heard. So there we are. That's the tests that I've done with these antennas in terms of SWR. What I'm going to do now is to switch off to save the battery, because it's the cheap version with the small battery and the nano VNA, and going to have a look at my phone, wherever that is, so that we can check the range tests. Here it is. Sorry about this, but I've stored the data on my mobile phone. So this is my results, which I've not written down for SWR yet, but I've written down the signal level received when those various antennas were connected to this node here to test to another local station that's about 1 kilometer or maybe 1.5 kilometers away. I haven't measured it, who has in fact an identical arrangement to this with that longer Chinese antenna. And I measured the signal strength received from that node. Let's say it's 1 kilometer away. Unfortunately, you don't get a reading of absolute received power in dBm. What you do get is RSSI, which is an indication of received power, which is not calibrated and it's relative, and nobody knows what to, and different manufacturers assign the numbers in different ways. So it's kind of meaningless except for comparison purposes. And what I've done is I've written down the received signal level. I made 3 tests, 3 trace route tests from one node to the other, and then took the average, because there can be very short-term changes and due to reflections from moving vehicles and people in the rooms, because I don't know what was happening at the other end when I did this experiment. Maybe the person with the other node was moving around, and that would affect the results drastically. or if you move the node. So you know who you are, by the way. So looking at this, the highest received signal level of minus 100 dBs, this is RSSI in dBs of course, was the medium plastic antenna. This is this one, which is 15 centimeters long from the Pi Hut, and that's the one that gave the best results. It's amazing, isn't it? And it's one of the smaller antennas, minus 100 dBs. Slightly worse, at minus 101 dBs, is the Superior from Amazon, which costs £35, not £5. That's this one. So it's 1 dB worse than this antenna. But there are so many factors that can change that I wouldn't trust that. So it's probably the same performance. The difference, of course, is that this is waterproof and can be managed outside. You can see I've got some outdoor brackets that goes outside in the rain, whereas this one I would not put outside in the rain. But it's fine for portable use or indoor nodes. So that's one of my favorite antennas at minus 101 dB. So as we go down, the very long plastic one gives minus 103 dBs. So it's 3 dBs worse than that antenna, which in terms of power means half the power. So I receive half the power level with this antenna than I do with that one. And that's 3 dBs difference. So it's usable, but the frequency is a bit unusual, the tuning resonance, and the SWR is not good, as we saw earlier. I'll write down the SWR in this column one day. So I've called it long wire, minus 104, because there's a short one as well. This is the longer one, the 30 centimeter long piece of twisted wire, which is a collinear antenna from Nuelec, which I didn't buy for Meshtastic, but I tested it. So it comes in at minus 104 dBs. And then No Name Tiny, that's this one, the one that comes for free with the Heltec boards bought on Amazon. Got a couple of those. And that one, No Name Tiny, is minus 105 dBs. So as you can see, we're going down in something like 1 dB steps, which is not bad when you consider the size of it, about 3 centimeters. You can see it's tiny. And then as we go down the list, LilyGo Tiny, that's the other one of those from LilyGo. It's interesting to note that they have different lengths. It doesn't mean that the antenna element's different, just the plastic case is different. Maybe one is a copy of the other. So this is the LilyGo version. That's actually slightly worse. You'd expect a branded device to perform better, but it's 1 dB worse than the no-name one. The short wire, that's this thing, which is not resonant at 868 megahertz, it's way higher. That was 109 dB, so that's really a big jump of 3 dB, it's a lot worse. And then going down, another 1 dB worse, minus 110, is this power radar antenna from eBay, which is supposed to be an 868 megahertz antenna. And you saw from the resonance curve, it has and also resonance up at 950. So it's a bit broadband, maybe, with a couple of resonances. And that antenna is sold as a 6.5 dBi antenna at 868 to 950 range. To be fair, that's what they said on eBay. Oh no, 815 to 896 they claim. So I mean it's broadband. Claims 6.5 dBi gain, but it comes out at minus 120 for the received signal level. So sorry, I said minus 110, which is not the best. The free stub, that's this thing that comes for free with the Heltec device in the box, that little stub antenna. I did a range test with that one, and that is the worst antenna. I mean, a lot worse. It's 9 dBs worse than the minus 110, so minus 119 dBs. That's, as you can see, that's 19 dBs worse than the best antenna, which is that one. 19 dBs is almost 20 dBs, and 20 dBs is 100 times. So if you've got 100 milliwatts with one antenna received, for example, then you've got 1 milliwatt received with the other one, which is a monstrous difference, 20 dBs. But there it is. These are my results. I don't claim they're accurate, but it gives an indication. The dummy loads I haven't tested yet. I'll probably do that in a separate video to see if I can get any signals out of those. Probably it's not worth it, because they're not supposed to radiate. If they're ideal, there should be 0 radiation from a dummy load. So there we are. That's the tests of the different antennas that I've managed to acquire for Meshtastic. LoRa 868 MHz antennas, or claim to be. Some work better than others. Let me know if you've tried any different antennas and what your results might be like. And in another video I'm going to connect one of my nodes to MQTT and play around with settings, because it's quite confusing, the settings in the Meshtastic software, to see what happens with MQTT and how you can use it or not use it and not flood the airwaves with unwanted nodes. So please remember to make some comments. I'm interested to know your experience with antennas, and perhaps if you've got suggestions what you'd like me to measure or do next, please make those suggestions, and see you in the next video.